Let's continue with the cyclogenesis and look at the Northwest Pacific. You remember this region is a hotspot for cyclogenesis and strong typhoons. The conditions here that have empirically been related to cyclogenesis are this monsoon trough. Not a terminology that is as well familiar in this region as it is over the Indian monsoon region, where there is a strong seasonal migration of the trough. In fact, it starts somewhere here, goes westward into the Bay of Bengal and then onto the Indian subcontinent and then retreats. One can think of all of those as part of the ITCZ, but we are separating the ITCZ here, which has a clear structure all the way to the northeastern Pacific towards the Gulf of Mexico, where there is another spot of typhoon generation. You remember they don't hit land, mostly go off into the ocean. So here are the trade winds, easterlies, northeasterlies and southeasterlies meeting into the ITCZ, extending all the way into the western Pacific and meeting the monsoon trough here. And the monsoon trough has several, it's a strong seasonality, of course, plus it can morph into a gyre, which you can think of here as a gyre, and then meet the ITCZ, and this region here is called as the confluence in this work by Briegel and Frank from 1997. And this region is also influenced by the so-called tropical upper tropospheric trough, which is emanating from the extratropics and has a strong connection to the tropics. And you can look up my lectures on tropical extratropical interactions in the either the S2S forecast course or the tropical dynamics course. Nonetheless, these are typical convective regions which have the ingredients of vorticity, instability, moisture loading, vertical motion, and so on. And this region is of course very warm. This is part of the Pacific warm pool and the Indo-Pacific warm pool, and moves back and forth with the sun. The warm pool is more focused in the south during the southern hemisphere summer, and then migrates back into the northern hemisphere during the northern hemisphere summer. So this thesis work by Guichard lists these kind of pathways through which the tropical cyclogenesis is associated with the monsoon trough. So you have the monsoon trough that we just looked at, which can break down and produce either multiple tropical cyclones or a single large tropical cyclone. The monsoon also gets into this gyre kind of structure, which can last for weeks, and or it can just become a sustained trough, which is basically a low pressure system. And the cyclogenesis has been observed in the trough, where it's related to this tropical upper tropospheric trough that we will look at in a minute that I just mentioned, and also has mesoscale convective system growth. Mesoscale convective systems are clusters of convection centers which are ideally already associated with convection, instability, vorticity, and so on, which are favorable for cyclonic growth. Okay, and you can have a confluence zone and equatorial wave enhancement, which we are not going to define very critically, but the MJOs, the easterly waves in the ITCZ, and the Rossby Kelvin waves of the MJOs are all equatorial waves which in certain phases can enhance the confluence zone that we defined here, and that can lead to cyclogenesis as well. And the outside the trough you have equatorial waves acting on the ITCZ wave guide, and waves, as we saw in the Atlantic with the easterly waves, are always associated with vortex. So vorticity seeding is always critical for cyclogenesis. Okay, looking at specifically the tropical cyclogenesis associated with the TUT, tropical upper tropospheric trough, as I said, which extends, it's a trough in potential vorticity. We already defined vorticity as zeta relative vorticity plus f the planetary vorticity. When we say potential vorticity, it's essentially because the atmosphere is stratified and vorticity is related to the particular layer, let's say, within the stratified medium. You can think of it as potential vorticity because as the layers squeeze and get thicker, you can think of as a ice skater that's stretching her hands out or bringing them in and changing her rotation rate, right? So the tooth is argued to assist by creating a divergence aloft, which is good for cyclonic outflow, so that favors the growth of the cyclone as opposed to a vertical shear which would chop it off. So it's a weak vertical shear and this divergence aloft which can favor cyclogenesis. So there is forced ascent associated with cyclogenesis or perturbation, disturbance that's at the surface that is trying to grow into a cyclone, let's say. So this is contribution of the tut to tropical cyclogenesis. The tut forces ascent. I'm calling it tut for whatever reason because I don't want to say each time tropical upper tropospheric trough in the region of the developing tropical cyclone, but provides very little vertical wind shear, which is favorable for cyclogenesis. So the storm convection and strengthening of the upper level outflow of the storm is favored. This can enhance tropical cyclone development. Okay, so again, typically after a cyclone is formed, you go back in time as much as possible to see what were the conditions that allowed it to grow from a seed. So this is kind of a tough business in terms of advancing process understanding. There are alternative monsoon trough modes. This is showing barotropic ITCZ breakdown simulations from a breakdown of the convective ITCZ in isolation or accelerated breakdown of the convective ITCZ in the presence of an existing tropical cyclone. Either tropical cyclone itself is creating a breakdown or the breakdown is happening within the convection of the ITCZ itself. The top panel in each pair is equivalent depth and lower panel is potential vorticity. Barotropic instability in simple words is instability of a horizontal shear as opposed to baroclinic instability, which is the vertical shear tipping over. So essentially you have available potential energy as horizontal shear, which can get converted into eddy kinetic energy, which is seen here as these cyclonic systems, a row of cyclonic systems in equivalent depth. In case you don't know what an equivalent depth is, again, in a stratified fluid, when you have waves moving, stratification means rotation typically. To determine the phase speeds of the waves, you look at the it's almost like a parameter, equivalent depth. So for barotropic instability, it's let's say order 10 kilometers, and for baroclinic instability, it varies, and usually it's used to fit the observed wave properties. So it's not, I don't know, let's leave it there. Okay, so here you have these cyclonic circulations set up by the spontaneous barotropic instability tipping over the ITCZ into kinetic energy and wave trains, and this is seen here also in terms of potential vorticity, which is essentially what we need for cyclone to grow, right? You need the rotation to start off, especially about 5 degrees away from the equator. So this is at 15 days before the cyclone. As I said, you always take a cyclone and you try to go back in time and see the conditions that led to cyclogenesis. This is 10 days before, and you can see that this is a cyclone that is already there. So you can see some so 5 days later there is already a cyclone here which is visible in the equivalent depth as well as the potential vorticity. So those are argued to be favorable for cyclogenesis in the monsoon. We didn't look at all the details of the gyre mode and so on and so forth, but as you can imagine, monsoon trough is a convective feature, and ITCZ is a convective feature. Both have waves, both are interacting, both have these mesoscale convective systems or convective cells and rotation, and they interact with this extratropical influence from the tropical upper tropospheric trough. So this region may be why is so active in cyclogenesis, cyclones, and very high intensity typhoons, right? And it is related to it varies on intriennial time scales with El Nino and La Nina. Global warming is affecting this region already in terms of the mean temperatures increasing, and MJOs under certain phases also add waves and convection over this region. So it's a very complicated region, but net effect is that it's very active in terms of cyclogenesis. Okay.